Okay, so what does a exponent do? What does it tell you? If I have x to the third, what does that mean? Your exponent tells you how many times you're multiplying the base by itself. So x to the third means you have 3 x's, xxx. X to the fourth means you have 4 x's, xxxxx. Okay? What if something doesn't have an exponent? It's an understood exponent of what? 1. Okay? So, let's expand these. X to the third means I have 3 x's. Do you need another? Okay, and what does x to the fourth mean? You have 4 x's, so write it out. This is called expanding it. Okay? So we expand it to visually see. How many x's do I have in all? 7. So I can rewrite this. 1, 2, 3, 4, 5, 6, 7 x's. So I can rewrite this as 7x. No. How would I rewrite this if there's 7 x's? X to the 7th power. Because remember, an exponent or a power tells you how many times you're multiplying something by itself. I have 7 x's here. So I have x with a power of 7. Okay? So we expand it so we can visually see how many we have. And then we count them up. There's 7 x's, so that becomes x to the 7th. Good? Okay, next one. A to the second means what? A 2 times. A to the fourth means what? A 4 times. So let's count them up. How many a's do you have in all? So a to the 6th power. Are we noticing something here, guys? What's the pattern we're seeing from my exponents in the original problem to the exponents in the answer? You what? You add them together. 3 plus 4 is 7. 2 plus 4 is 6. So that's what the rule is. You keep the base and you add the exponents. Okay, so circle it, star this, highlight it, box it, whatever you want to do. But that is very important when you are multiplying two things with the same base. So like here, x and x, they both have a base of x. You keep the base and add the exponents. Okay? Now, sometimes your variables are going to have coefficients. Okay? So are we okay to maybe try to use the rule? Okay? You have a coefficient of 2 and a coefficient of 3. Those are just numbers. Okay? They're not exponents, they're coefficients. We're following the rules we've always used with coefficients. What is 2 times 3? 6. Then I have a to the third and a to the second. So how many total a's are there? 5. So a to the 5th. Multiply your coefficients like we've always done. And then add your exponents. We good? Okay, next one. 3 times negative 4. What's 3 times negative 4? Negative 12. Good job. And then I have 4 a's here and 6 a's here. So how many a's, excuse me, how many a's in all? So a to the 10th power. We go with those? Yeah? Okay. Now guys, I will tell you this is not super difficult. What we're doing today is not super difficult, but there's 5 different rules. Do you think all 5 of the rules are going to be different? Yeah, we're not always adding the exponents. Sometimes you're multiplying them, sometimes you're subtracting them. So that's where it gets kind of tricky, okay? So make sure you're looking at your rule. See how these both have bases, and they're the same, and they both have exponents. Keep the base, add the exponents. Now, if I look here, this one's called power of a power property. The reason is I only have one base. Do we all see that? It's not like 2 to the 4th power and then 2 to the 2nd power. It's 2 to the 4th power, then raised again to another power. Do we see how this one looks differently than these? There's only one base, okay? So we're going to do like we did at the beginning. I'm going to expand this. I have parentheses to the 2nd power. So how many times are you going to write the parentheses out? 2 times. So 2 to the 4th, 2 to the 4th. Now does this look like the ones we did up top? Do I have 2 bases that are the same? Yeah, keep your base and do what to the exponents? Add them. 4 plus 4 is 8. So 2 to the 8th power. Now, since that's not a variable, it's a number, can we actually calculate what 2 to the 8th power is? Yeah, let's go to our calculators. Two raised to the 8th power. And we get 256. Would I accept either of these as correct answers? Yes, I would. Okay. Look at the next one. I have parentheses to the 4th power. So how many times am I writing the parentheses out? 4 times. So 3 to the 4th, 3 to the 4th, because remember, exponents tell you how many times you have something multiplied by itself. So I have parentheses to the 4th power, meaning I have the parentheses times the parentheses 4 times. Keep your base. They all have the same base of 3, 3, 3, and 3. Keep your base. And what are we going to do with our exponents? Add. What's 4 plus 4? Plus 4? Plus 4? So to the 16th power. And again, that's not a variable, so I can do 3 raised to the 16th power. And you get a really big number. 43,046,721. Okay, let's see if we can look at a pattern here, identify a pattern. How do I get from my exponents of being 4 and 2 to now being an exponent of 8? Multiply. What's 4 times 4? So do we see that that's the rule for this one? If you have a base, if you have something raised to a power, then raised to another power, you just multiply the 2 powers. Okay? So looking here, I have x to the 2nd power to the 3rd power. There's only one base. My base is x. Raised to the 2nd power, then raised to the 3rd power. So when you have a power raised to another power, what do you do with the exponents? Multiply them. So this is going to become what? X to the 6th power. Now guys, do I care if you use the expanding way or if you use the rule? Makes 0 difference to me. Some of y'all need to visually see us expand it. And if that's you, great. Okay? Some of us will probably make more mistakes when we expand it, because if it says So this I would have to write out 4 3s, 4 3s, 4 3s, 4 3s. That's a lot. What if I accidentally wrote only 3 3s in one of the parentheses? Or what if I accidentally wrote 5 3s in one of the parentheses? Then whenever I count it up, it would be wrong. Okay? So some of us are going to make more mistakes when we expand it, but some of us are going to need to expand it. I do not care what you choose to do. Good? That's why I'm kind of showing you both ways. Okay? Next one, power of a product property. Okay? That means I'm going to have multiple bases. Do we see in the parentheses here, I have a -3 base and I have an x base. I have two bases that are both being raised to what power? The second power. Okay? So let's expand this. I have parentheses to the second power. So how many times do I write the parentheses out? Twice. Very good. So -3x and -3x. So you expand it to get rid of the exponents. I no longer have any exponents. Now we're going to put it back together to make it look nice and neat. Your coefficients are just numbers that followed the same rules they've always followed since elementary school. What's -3 times -3? 9. Positive 9. And then I have how many x's? So it becomes x to the second power. Good with that? Okay. I'm going to work down. Okay. So I have parentheses to the third power. So how many times do I need to write my parentheses out? 3 times. Now let's count up our x's. How many are in my first parenthesis? 2, then 2 more, so I have 4, then 2 more. So this is x to the 6th power. And then 1, 2, 3 y's. So y to the 3rd power. We good? Done. Does anyone notice the pattern here? If you have two bases in the parentheses raised to a power, what do I do with that power? Multiply it by both of my bases' exponents. If you don't have an exponent, what's your understood exponent? 1. So I'm going to put a y to the 1 to help me a little bit. So what's 2 times 3? Do I have x to the 6? Yep. What's 1 times 3? 3. So I have y to the 3rd. Okay, it's almost like you're distributing that exponent to both of the bases inside the parentheses. Okay? We good with that? Do we want to use the rule now? Instead of writing it out? Okay. Anything that doesn't have an exponent, put an exponent of 1. Okay? Anything that doesn't have an exponent, put an exponent of 1. It's going to help you. Okay, so I'm going to put my 2 with an exponent of 1. Okay? So this is -2 to the 5th power. Because what's 1 times 5? 5. So -2 to the 5th power. Then I need to multiply my x's exponent. So x to the 2nd to the 5th becomes what? X to the 10th. And then y to the 3rd to the 5th? Y to the 15th. Okay. It is kind of tricky when we are doing negative numbers raised to a power. This one, it won't affect your answer if you put it in the calculator with or without the parentheses. Half the time it will. If your exponent's even, it's going to affect your answer. If your exponent's odd, it's not going to affect your answer. But so why I'm saying that is I want y'all to get in the habit of putting your number, your coefficient, in parentheses when you raise it to the power, because half the time it's going to be affected. So parentheses, -2 raised to the 5th power. Let's all type this in the calculator with me. -2 raised to the 5th power. And we get -32. Very good. X to the 10th, y to the 15th. And there is your answer. The biggest mistake with our exponent properties, guys, are people multiply our coefficient with the exponent. People do -2 times 5, because I say we're multiplying, right? So people do -2 times 5 and give me a -10. This 2, this -2 is a coefficient. The 5 is an exponent. You're never multiplying coefficients with exponents. You're raising coefficients to an exponent, okay? It's easier with the variables because you're not going to be multiplying a variable with an exponent, okay? Okay, let's look at this next one. This 3x to the 4th power, is this in parentheses? So am I going to distribute that exponent of 2 to the 3 or to this x to the 4th? No. This 3x to the 4th stays 3x to the 4th power. Does my 2 have an exponent? It doesn't have one written, so I'm going to put a 1 there. Does my x have an exponent? No, so I'm going to put a 1 there. Okay. So I have 2 bases in the parenthesis. Both of these need to be raised to the 2nd power. Okay? So 1 times 2 is 2. So this is 2 to the 2nd power. And then 1 times 2, so x to the 2nd power. We good with that? Now guys, does that look nice and pretty? Or does that still look pretty ugly? Ugly, right? So we're not done, okay? I'm going to keep my 3x to the 4th. What's 2 to the 2nd power become? So times 4. And then we can't simplify x squared. Anyone see anything else we can do? We have coefficients. That says 3 times 4. Pretend the x's aren't even there. Can we do 3 times 4? Yeah, what's 3 times 4? 12. So 3 times 4 is 12. And then I have how many x's here? 4. And how many x's here? For a total of how many x's? 2 and 4. 6. Remember, you only multiply the exponents whenever there's only one base. These both of these exponents have their own base. That's when you add them. Okay? We good? Okay, let's do the next one. Does my 5 have an exponent? It's not written. Very good. So I'm going to put a 1 there. Okay, so 1 times 3. So this is 5 to what power? The 3rd power. Very good. Does my x have an exponent? Yes. So 4 times 3. So x to the 12th power. Does y have an exponent? Doesn't have one written, so put a 1 there. What's 1 times 3? So y to the 3rd power. Well, what is 5 to the 3rd power? Remember, a power is not meaning you multiply the 5 and the 3. 5 to the 3rd power means 5 times 5 times 5, which is 125. Are any of these like bases? I have a coefficient, I have an x, I have a y. Are any of these like bases? No, so I can't do anything else. We are done. Okay? So when you have two bases or multiple bases in the parentheses raised to a power, you raise every base to the power. Okay? We good with that? How are we feeling? Okay? Ish? Don't worry, we're going to be doing lots of practice. Okay, now we're going to go on to our division properties. I think the division ones are actually easier. Okay? So, we're going to expand it first. Okay, then we're going to look at the rule. What's 3 to the 5th power mean? I have 3 5 times. Over. What's 3 to the 3rd mean? 3 3 times. Now, when you have the same factor on top and bottom, like what's 2 divided by 2? 1. So can I cross these out if there's something like on top and bottom? Yeah, because then that's just a 1. And when you multiply by 1, does that change anything? Nope. So they cancel each other out. I have a pair of 3's that cancel out. I have another pair of 3's cancel out, and I have another pair of 3's that cancel out. Can I cancel out these two 3's? No, because they're not both, they're both on top. There's not one on top and one on bottom. That's the only time you can cancel, is when one's on top, one's on bottom. Okay? So this becomes 3 to what power? The 2nd power, because I have 2 3's. Are my 3's left in the numerator or denominator? Those 3's are on the bottom or the top? The numerator, the top. So my answer, the 3's are on top. Well, if there's nothing left on bottom, you don't need to put the fraction bar. Okay. Well, what is 3 to the 2nd power? 9. Okay, so let's look here. How did we get from exponents of 5 and 3 to an exponent of 2? What did we do with our exponents 5 and 3 to get an exponent of 2? Subtract them. So when we're dividing, you subtract the exponents. When we multiply, you add the exponents. When we divide, you subtract. Does that logically make sense? Adding and subtracting are opposites of each other. Multiplying and dividing are opposites of each other. Okay? The only tricky thing is you need to know where your base should be, whether it be in the numerator or the denominator. Okay? So what I always do, I don't want to expand this. I think it's going to be way easier just to see. How many 3's are on top? 2. How many are on bottom? So are there more 3's on top or bottom? Bottom. So I'm going to put over 3. I know my 3's have to be on bottom because there's more on bottom. How many more are on bottom? What's 8 minus 2? So there's 6 on bottom now. Unlike when you have more on top in the numerator, it's just a whole number. If you have more in the denominator, what do you have to put now in the numerator? A 1. Do we see how this logically, again, I think this is more logical. Are there more 3's on top or bottom? There's more 3's on bottom. Keep the 3 on bottom. How many more are there on bottom? 8 minus 2 is 6, so there's 6 more on bottom, so 3 to the 6th power. Okay? Now let's do, what is 3 to the 6th power? 729. So this is 1 over 729. Now sometimes there's going to be multiple bases on top and multiple bases on bottom. Okay? So first look at your A's. I have A's on top, A's on bottom. Are there more A's on top or on bottom? Look at your A's. How many are on top? 2. How many are on bottom? 8. So are there more on top or bottom? Bottom. So I'm going to do my fraction bar and I'm going to put A on bottom. How many more are on bottom? 6. Don't put a 1 in the numerator yet because there might be a base that stays in the numerator. We don't know yet. So now let's look at our b's. I have b's on top and b's on bottom. Are there more b's on top or bottom? By how much? 9 minus 4 is 5. So b to the 5th goes on top. Good? When we are doing our division, make sure that and when we're doing our multiplication properties, make sure that you don't have the same base written multiple times. So if I still had an A on top, I wouldn't be done. Or if I still had a B on bottom, I wouldn't be done. I only can have one base of B and one base of A. Okay? That is simplified. Next one, look at your 2's. 2 doesn't have an exponent in the denominator, so it has an understood 1. Okay, so are there more 2's on top or bottom? By how much? 2. So 2 to the 2nd on top. Are there more 3's on top or bottom? Bottom. By how much? 2. So 3 to the 2nd power on bottom. Are there more 5's on top or bottom? Top by how much? 7 minus 5? 2. So 5 to the 2nd power. Now we want to simplify this. Okay? What is 2 times 2? Or 2 squared? 4. What's 5 squared? Over. What's 3 squared? 9. What is 4 times 25? 100 over 9. Now, remember, we always want to simplify fractions. So let's type this in our calculator to see if this simplifies. Alpha y equals enter. Let's all put it in our calculator. It's been a while since we've used these. Alpha y equals enter. 100 over 9. And it stays 100 over 9. Cannot simplify. So when we're dividing, we subtract our exponents. Okay, always do the big exponent minus the small exponent. And then if it's on top, if there's more on top, it goes on top. If there's more on bottom, it goes on bottom. Okay, we good with that? Okay, now the last property is essentially what we've already done. When you have multiple bases in the parenthesis, what do you need to do? Raise everything to the exponent, the power, okay? It's just now in the parentheses we now have a fraction instead of a non-fraction, a whole number, okay? So, your 3 doesn't have an exponent, does it? Put a 1 there. So what's 1 times 3? 3. So this becomes 3 to the 3rd power. Over 4 doesn't have an exponent, so put an exponent of 1. 1 times 3 is, so 4 to the 3rd power. Do you see how this is essentially what we just did on the front? You're distributing that exponent to every base in the parentheses, raising every base to the power. Okay, so what is 3 to the 3rd power? Don't tell me 9. Remember, 3 to the 3rd power means 3 times 3 times 3. 27. And then what's 4 to the 3rd power? Don't tell me 12. 4 to the 3rd power means 4 times 4 times 4, which is 64. Good? Okay. Before you distribute the exponent to all of the bases, do you think it would be a good idea to simplify what's in the parentheses? If your parentheses is simplified, you have to do less work. You don't have to distribute as many times. So it's not wrong if you don't simplify the parentheses first, but it's a good idea too. Okay? So looking in my parentheses, I have a 2 and x's on top. I have an x and y on bottom. Is there anything alike on top and bottom? I have x's on top and x's on bottom. Your x doesn't have an exponent on the bottom, so put a 1 there. So are there more x's on top or bottom? Top by how much? 2. So I'm going to rewrite this as 2x to the second over y to the third power. Are we okay with how I got that? 3 x's on top, 1 on bottom. 3 minus 1 is 2. There's more x's on top, so x to the second's on top. Good? Now there's nothing alike in the parentheses, so now we're going to simplify it. We're going to distribute that exponent to every base. Okay, the 2 has an exponent of 1. So that becomes 2 to what power? The third power. Very good. Then I need to distribute the 3 to the 2. So that becomes x to the 6th power. Very good. Over. Does your y have an exponent? Yeah. Has an exponent of 1. So 3 times 1 is? So y to the third power. Now what is 2 to the third power? Two times 2 is? 4 times 2 is? 8. So 2 to the third power is 8. So this becomes 8 x to the 6 y to the third. Are there any like bases here? No, the top has an x. Sorry, the top has an 8 and x's. The bottom has y's. There's no like bases, which means I'm done. Okay? How are we feeling with these? This one's kind of putting all of it together, right? Okay, let's look at the next one. On top I have 6 A's and B's. On the bottom I have 3 and C's. Anything I can simplify? The numbers, the coefficients. What is 6 divided by 3? 2. So it's 2ab to the third over c squared. Those are numbers. Those are just coefficients. Follow the rules that we've always followed. Okay, that says 6 divided by 3, which is 2. 2 is a whole number, that's why it goes on top. Okay. So now we need to distribute that exponent. 2 has an exponent of what? 1. So this becomes 2 to the second power. Very good. A has an exponent of 1. So that becomes a to the second power. And b has an exponent of, so that becomes b to the, and then over, what's that become? C to the fourth. What's 2 squared? 4. So 4 a squared b to the 6 over c to the 4th. Good? 2 more, guys, and we're done. Y'all are doing a great job. Okay, so this one, you cannot start crossing things out because my numerator's in parentheses and the denominator's not in parentheses. You only can simplify your fraction if they're both outside parentheses or both inside parentheses. Right now, the numerator's inside, the denominator's outside, so we cannot just start crossing off these -5s, the v's, and the t's. It does not work like that, okay? So we're going to first just look at the numerator, and we're going to simplify just the numerator. Okay, I have 3 bases here. I have a -5, a v, and a t. I need to raise all of those bases to what power? The second power. Very good. My -5 has an exponent of 1, so that's -5 to the second power. My v has an exponent of 1, so that becomes v to the second power. And my t has an exponent of 1, so when I distribute the power, it becomes t to the second power. Over, and we're just going to leave the denominator as is, because there's no parentheses. Okay, what's -5 squared? Positive 25, because a negative times a negative is a positive. So this becomes positive 25 v to the second t to the second over -5 vt squared. Good? Okay, what's 25 divided by -5? -5. Divide your numbers, your coefficients, just like we always have. Okay, that says 25 divided by -5, which gives you -5. Now, are there more v's on top or bottom? Top by how much? 1. There's 1 on bottom and 2 on top. So v to the first power, but do you need to write a power of 1? No. Okay, then are there more t's on top or bottom? They're equal, so they just cross out. If you have the same number of something in the numerator as the denominator, they just cross out. Phones are away. Okay? Does this look way prettier than what we started with? Yeah, we're done. That's your answer. How are we feeling, guys? Give me thumbs. Remember, an iffy is okay. Okay? I don't see any thumbs down, so I guess that's a good thing. Really, guys, the only way to get better at these is practice them. There's so many different ways it can be represented. I cannot do an example of every way it's going to look. Okay? Okay, let's look at the last one. Again, I cannot just start canceling stuff because the numerator is in parentheses and the denominator is not in parentheses. Okay? So I need to simplify the numerator first. This -2 has an exponent of 1. So it's going to be -2 raised to what power? The 5th power. Very good. My n also has a power of 1. So this becomes n to the 5th power. There's no parentheses or anything to simplify in the bottom, so just carry that over. Okay, so let's see. What is -2 raised to the 5th power? -32. So I get -32 n to the 5th over -2 n to the 5th. So I simplified the numerator. Now let's simplify the whole entire fraction. You have coefficients. Simplify your coefficients. What's -32 divided by -2? Positive 16. What happens to your ends? They cancel out. You have 5 on top, 5 on bottom. They cancel each other out. So do I have any ends left? No, so my answer is just 16. So my rule is when you have multiple bases in the parentheses, distribute that power to all of the bases. Okay? Again, It's not wrong if you distribute the exponent first, then simplify the fraction. However, if you have a fraction in the parentheses, it's easiest and saves you a little bit of time if you simplify what's in the parentheses first, then distribute the exponent. Okay? We good? Okay, I need everyone to get a computer and get started on your Delta Math homework. Okay? Yeah. No, you can.